In another video, we learned how the base tables and the navigation of a web panel with several grids were determined. In particular, we saw an example of nested grids performing a join. That is, the external grid ran through a table with a 1-to-n relationship, with the table run through by the internal grid, regardless of whether these grids were implemented with or without a base table. In both solutions, the web panel received a country identifier and a parameter, and the external grid showed the cities of that country. That is to say, it was going to run through country city, and the internal grid showed the tourist attractions of that city. In other words, it was going to run through attraction. In the case of grids with a base table, this join was established automatically without having to do anything. Genexus detected it and added the filter in its source program. On the other hand, in the case of grids without a base table, we had to specify it in the for each that we implemented to load the nested grid, and we only filtered by city, because the filter by country was already implicit by receiving it in a parameter in the country ID attribute. Here's the web panel with both grids with a base table. We've added an action in the country's work with pattern in order to invoke this web panel. If we choose France, here we see the attractions of Paris and Nice, which are the two cities we've entered in the system. Now let's see what happens if instead of choosing France, we choose Brazil, for example, which also has two cities entered. We see that for the first one, Rio de Janeiro, a tourist attraction is shown, but for the second one, Sao Paulo, no tourist attractions are shown. This is precisely because it's a join. The refresh of the external grid will be executed first, and then, once positioned in the first city, Rio de Janeiro, it'll be loaded in grid 1. Right after that, the refresh of the nested grid will be executed, and then the attractions of Rio de Janeiro will be loaded, which in this case is only one, Christ the Redeemer. Then the next city, Sao Paulo, will be loaded, and the nested grid will be refreshed. But when running through the table of attractions to load only those of Sao Paulo, none will be found. In order to show only cities with attractions, we need to implement a control break and not a join. We had outlined a case where an unwanted control break would occur instead of a join, but we'd only addressed that by not specifying a base transaction for the nested grid. It appeared to be country city, but actually it would be attraction. We hadn't looked closely at the navigation, and now we'll do so with our example. We need, as in the case of a listing, that both for each commands, either implicit, in other words, coming from grids with a base table, or explicit, in other words, coming from grids without a base table, have the same base table attraction, and that the first one makes up the group that's going to make the break by country/city. To do so, it's enough to modify the base transaction and add the order to the first grid. It'll depend on whether grids were implemented with or without a base table to see how to do it. Let's start by the case in which the web panel was implemented with both grids with a base table. In this case, the objective is achieved by changing the properties that we see of the external grid for these others. Before doing it, let's go to Genexus. We see the properties of both grids. The first one has a base trn country.city and no order. The second one has base trn attraction and an order by attraction name. And in the events, we see that the refresh and load events have been programmed for each grid, only to initialize and sum or count in variables, which will show the total number of attractions loaded, and the total number of trips in which those attractions are included. We also have user events to call various objects. They don't matter at all here. In Genexus, let's look at the navigation list of the web panel. We can clearly see the base table of the first grid, country city, which will filter by the country received in a parameter. Next, we go to the nested load, which has attraction as a base table and filters by the country and city of the external grid. Of course, we see the join. Also, note that it orders the first implicit for each by country ID and the second one by attraction name, for which it reports that there's no index. The pseudocode of the source that Genexus will program will be similar to the one displayed. In it, the base transaction property of grid 1 was used to program the base transaction of the implicit for each. In the second for each, the order clause set was the content of the grid's order property, which was attraction name, and that's why we saw those selected indexes. In short, the refresh of the external grid will be triggered. And then, the implicit for each that we're seeing, which together with the internal one will make up a join. Now let's modify the properties of grid 1, the external one. In doing so, the base transaction property of the grid will cause the base transaction of the implicit for each to be modified, and the order property will become the order clause of that for each. This will be enough because the refresh of the external grid will be triggered, and then the implicit for each that we're seeing, which, together with the internal one, will make up a control break. Therefore, tourist attractions are going to be grouped by cities of the country. The filter by country ID is due to the parameter. Therefore, for each group of tourist attractions formed by each city, the load event will be triggered once. Then the first line will be loaded in the grid, with the city name of the city of the first group of attractions, and of course, its country name, which will be the same for all of them. Next, the refresh event of the nested grid will be triggered, after which the implicit for each will be executed. And it'll only run through the attractions of the group, in other words, those of that country and city. For each one of these attractions in the group, it'll trigger the load event and the load command to load it into the nested grid, and so on with all the groups. If we look at the navigation list, we can clearly see that both grids will navigate the same table, attraction, using an index made up of the attributes of the order property of the first grid plus the order of the nested grid. And we can clearly see that for the nested grid, only the attractions corresponding to the country and city of the first grid will be run through. If now we try it at runtime, we see exactly what we wanted. Take China, for example. Perfect. And if we go to France, in this case, we don't notice any differences with the case of a join, but the attractions are not being counted correctly. Why is that? In grid 1, we're using the count formula to count the attractions corresponding to that country and city. This worked when the base table of the for each was country city, but not now that it's attraction. The problem with the formula of the first grid is clear in the navigation list. We can't run through a table and make an aggregation on the same table. For this to work, we would have to use the unique clause, which in this case is not useful because it's not supported for control breaks. We're talking about the control break between grid 1 and grid 2. Therefore, we could make this calculation with another for each by implementing another control break nested to the outermost for each. But this is not what we need. We would have one control break split into two instances, but the first one would run through all the attractions of the city, and the second one would have no attractions to run through it. But we have a much simpler solution. Since the number of attractions will be the sum of all the records loaded in Grid 2, we could have deleted the load event from Grid 1, and then added the sum to the load of Grid 2 without reinitializing the variable other than in the refresh. This makes it much simpler. If we run, for example, for France, with its 2 cities, no difference can be seen with the implementation with a join because both cities have attractions. But if we choose Brazil, we do see the difference. Or China, for example. And now the attractions are being counted correctly. Now let's move on to the implementation case without a base table. We had this web panel that implemented the same join as in the beginning, but without base tables. Note that in the screen, we only have variables, and there are no attributes in the properties of any of the grids. In the events, we explicitly performed the database loading. Let's do a save as to leave this one as it was, with a join, and implement the control break in another. We take this opportunity to remove the count of attractions from the first load and count in the second one to make everything simpler. Now let's modify the work with country action to invoke this web panel. Let's run and see the attractions of France. And now those of China. The join is clearly noticeable and not the control break. Even though the load command of the first grid triggers the refresh event, and immediately after that the load of the second grid, it doesn't really nest the for each commands. It's as if a subroutine were invoked, as if the for each of the nested grid were executed in isolation. That's why Genexus is not finding an automatic join, and we had to explicitly filter the attractions of the city that was loaded in the city name variable, which was loaded by the load event that invoked the load of the nested grid. We didn't also have to place a filter by country ID because it's instantiated in the parameter. Let's keep this in mind, because it'll make this case less obvious than it might seem at first. The question is, how do we make the for each corresponding to grid 1 change its base table to attraction and establish a control break by country, city? It won't be by adding base TRN or order to the properties of grid 1, because if we did that, we would transform the implementation into one with a base table, but to the explicit for each of the load event of grid 1. Therefore, it seems obvious that the first thing to do is to modify the first for each so that the base transaction is attraction. And it would also seem obvious that we should place an order clause to establish the grouping criteria by which we want the control break to be established in relation to the for each of grid 2. However, if we look at the navigation list, it seems a bit odd, and although every for each apparently does what it should do, it didn't choose the same order for each one, in order to use a single index and make the run-through more efficient. Something's not right. It obviously didn't understand that it will have to make a control break, and we can confirm this by running it. Note that for the attractions in France, Paris comes up twice, corresponding to the 2 Paris attractions that are available. For those in China, Beijing comes up 3 times, corresponding to the 3 Beijing attractions. And for Brazil, only once, matching the Rio attractions registered. Obviously, it doesn't realize that it has to make a control break. This is because, as we've already mentioned, it doesn't really nest the navigations. It's as if they were 2 independent for each commands, only that from one the execution of the other is invoked, but through 2 separate queries to the database. This is the equivalent of saying that we cannot really implement a control break between 2 nested grids without base tables. The solution we have for the moment is to use, for the first for each, the unique clause. In other words, if several records in the attraction table have the same country and city, it'll keep only one of them. And for this one, load the variables and execute the refresh event. And right after that, the load of grid 2, which will execute its for each as if it were completely independent of the previous one. And that's precisely why this time it'll allow us to use the unique clause. If now we look at the navigation list, it seems that it'll work this way. We run it. And we have succeeded. So for the moment, we're finding it much easier to implement a control break when grids have a base table. Strictly speaking, it'll be a true control break only in that case. In the second case, when grids don't have a base table, we're just simulating it. But actually, there will be 2 independent queries to the attraction table, and not a single one that solves everything, as it happens in the real control break. We encourage you to try everything that we've just seen.